Welcome on this video tutorial. Now we are going to discuss about the counter operation of 8051 microcontroller. In this video tutorial, we will discuss how microcontroller timer can be used as a counter. What are the different settings at TMOD register to function the timer as a counter. We will discuss about which external pins are used for the case of counter operation. We will discuss how the counter operates in mode 1 as well as in mode 2. We will discuss the counter operation with examples. We will try to write the program, step by step program, to explain, to understand how timer can be used as a counter. Here we will discuss about the TCON register, what are the functions of different bits in TCON register. We also discuss about function of gate bit in TMOD register, how the gate bit is used for the case of software run as well as the hardware run. For the case of hardware run, which microcontroller pins are used, we will discuss about all of this. Now I am entering into the discussion. What is the basic difference between the timer and counter programming? For the case of counter programming, the C/T bit in TMOD register should be logic 1. Next, for the case of timer, what will happen? Some external signal should be given at particular pin. This is the pin diagram. Pin number P3.4 and P3.5. This P3.4 and P3.5, here it is written timer 0 and timer 1. So this two pin is connected with the timer register, and when we will use the timer as a counter, these two pin should be used. Any one of these we may use. Say for a counting operation, here some signal is given. Say a particular square wave is given. So for every high pulse, every high portion of the pulse, it will give a particular pulse into the timer, and that will be incremented by 1. So here this is used as the counter. Counter means if we give here 1 pulse, the timer will be incremented. Better we should call it counter, not timer. So when we are using C/T is logic 1, then better we always mention it as the counter. So how this counter will work? When a pulse signal will be given at P3.5, say we are using 3.5, that is timer 1. So when a pulse will be given at 3.5, the counter value will be incremented by 1. So by using this, we can count external effects, external signals. Means say in a bottle filling system, say number of bottle will be counted. When one bottle is coming, one signal is here, so it will be counted 1. Next bottle is coming, another signal will be here, it will be counted, incremented by 1. Like this, it will count the total number of bottles which is giving the signal at pin number P3.5. So for the counter operation, we may use P3.4 if we are using timer 0, and for counter operation we may use P3.5 for when we are using timer 1. So this is the basic function. What is happening here? First thing, C/T, this is that bit into the timer TMOD register. So this C/T should be set as 1. Now any pin we may use pin number P3.4 or 3.5. We may use any pin. When the input signal is coming here means at pin number 3.4 and 3.5, when the input signal is coming here, and if the timer is 1, and this is a AND gate, if the timer is 1 means this pin is totally 1 means logic 1. So for a particular pulse, this is 1 pulse. When a particular pulse, this pulse, say this pulse, when this pulse will come here, it will give 1 pulse at the output of AND gate. So the value will be incremented by 1. For the next pulse, another logic 1 will be here, so that will be incremented. So whatever the number of pulse will come here, according to that number of pulse, this will be incremented, and it will ultimately give a particular value. Now similarly, what will happen here? This is using in mode 1 because timer high and timer low both we have used here. So for this case, the final value is FFFF. So in this situation also, when the final value will reach, after that it will start from 0, and that is normally called the rollover situation. At this rollover situation, the timer flag will be high. Similarly, the timer can be used in mode 2. For this case, when the mode 2 will be operated, this part is same. What will happen? This TL value will be incremented, and ultimately when it will reach to the highest value, that is FF, then flag will be high. Status, we may check this status and we can do different things as per our requirement. So this is counter operation using the timer 0 and timer 1. There is the question: assuming that clock pulses are fed into pin T1, write a program for counter 1 in mode 2 to count the pulses and display the state of the TL on count on P2, which connects to 8 LEDs. First we must set the TMOD register, timer 1 and mode 2, as it is counter 1, timer 1, mode 2. So it should be the value of TMOD. This is timer 1 mode 2. Timer 1 means first 4 bit. First 4 bit, that will be 20. Timer 1 mode 2, the value will be 20. So the instruction is move TMOD comma hash 20h. This is the first thing. Or not 20, because TMOD, the total bit was, first bit was get, next bit was C/T, next bit was M1, next bit was M0. What will happen? As we are using the software run, so this is no doubt 0. Now what is the value C/T? As here we are using the counter, so the value will be 1. Next, as this is mode 2, so this will be 1 0. So ultimately the value will be this. What will be this value? This is 4 to 6. So this will be 6 0. This 0, from where this 0 came? This 0 came from here, the timer 0, from the timer 0 part. Means again the 4 bit will be here. So this first thing is set up which timer we are using and in which mode. Next we should initialize the timer. So for this case, as we are using the counter, so initial value always should be 0, and as this is the mode 2, so we should give the initial value at higher byte of the timer. So the initial value should be given here. What will be the initial value? Initial value should be 0, as we are using the counter. Counter means when the first object will come, then it will start increment to 1, that is 1. So the instruction will be move TH1 comma hash 0 in decimal, hex, whatever might be, no problem. This is the initial value. Next what we need, as this is the input pin, means we are taking the signal from the outside, so this pin should be set as input pin. For this case, this instruction is required. Set bit P3 and which pin? Say timer 1 we are using, so P3.5. The pin is P3.5, set bit P3.5. This is initializing the pin as input pin. যদি আমি কোনো পিনকে ইনপুট পিন হিসেবে কনসিডার করতে চাই, তাহলে আমাকে কি করতে হয়? সেটাকে ইনিশিয়ালাইজ করতে হয়। আউটপুট পিন হিসাবে ইনিশিয়ালাইজেশনের কোনো দরকার হয় না। তারপরে কি করব? তারপরে আমরা টাইমারটাকে রান করব। সো run the timer. Instruction is set bit timer run. Which timer we are using? We are using timer 1. So set bit timer 1. আমরা টাইমারটাকে রান করলাম। টাইমারটাকে রান করলে কি হবে? Automatically, according to the input value at pin P3.5, timer will be incremented. Now timer কোথায় increment হবে? As we are using the timer in mode 2, so TL is ultimately effective part, TL. This will be incremented, not TH. As this is mode 2, mode 2 is the 8-bit operation, so TL will be incremented. And according to question, the value from the TL will be taken to port P2, because P2 is connected with the LED. Means what will be the value? If TL is 1, then it will glow say 1 LED. If TL is 2, it will glow 2 LED, like this. LED is connected with port P2, so the value of TL should be taken to P2. How this value can be taken? For this we will use the 2 instruction, move A comma accumulator comma TL1. So the count value from the TL1 to will copy to A, and this will be transferred into the port P2 comma A. So by this two instruction, what will happen? The counted value from the T1, this will be copied into A and from A to P. Means whatever the value in TL, that will be copied into P2. Means if TL is 1, P2 will be 1. If TL is 2, P2 will be 2. If TL is 3, P2 will be 3. If TL is 4, P2 will be 4. Like this. This will be continuously going on. So according to question it was that whatever is the value at the timer, the same value will be loaded into the port P2, and this P2 is connected with 8 LEDs. So this is the normal operation. Next, for completing the program, what is needed? We should check the timer overflow flag. So the same instruction JNB TF1 comma here, and the label here is in this position. So until and unless, one thing here, what is needed, when the timer is say value 1, it will be copied into the port P2. Say timer is 1, it will be copied into port P2, means P2 value is 1. Again timer is incremented. When timer is 2, then same value should come to P2. So in this case, at this position, some repetition should be required. What is that repetition? Repetition is, say when the timer value is 1, the P2 value is 1. Now it should check whether the timer flag is high or not. It not reached to FF value, so it should again go back. Now where it should go? It should again take the value from the timer to P2. So it is better to use the loop from here. What is happening? Timer value taken to P2, it checked whether it is it reached to the highest value or not. Again it will repeat, take the next value, say it is incremented by 1. Again the same value goes to P2. This will continuously repeat. Means whatever the value at the timer, because of the presence of the external signal, the same value will come to port P2. So it is better to use the label at that position. So what are the next thing needed? When the value reaches to highest value, means when JNB is equal to TF1 is equal to high, means the highest value reached, then what should we require? First we must clear the timer flag TF1, or we should stop the timer run on. If we want to repeat the same thing, means to continue the counting again, what should we do? Just a short jump. Now where the short jump will be there? The short jump will be and the level will be at this position, means again it will start the timer. So the level will be, this is the total program. This is all about how a counter can be used, or a timer can be used as a counter. আমরা যে কোনো একটা পিনকে ইউজ করতে পারি. If we use P3.4, then the timer 0 will be used. If we use P3.5, then timer 1 will be used. Both timer can be used, mode 1 and mode 2, both. What is TCON register? TCON is the timer counter control register. Timer counter control register. TCON is the timer counter control register, means whenever the timer will be used as a timer or will be used as a counter, so that operation of the timer or counter can be controlled by using this register. Now what is the different bit in this register? Now I am explaining only the higher 4 bit. Lower 4 bit I will explain later, because the lower 4 bit is related to the interrupt. This lower 4 bit is related with the interrupt. So when we will go through the interrupt portion, then we will study about this lower 4 bit. Only the higher 4 bit already we have used. The higher 4 bit. What is this? This is the TR0. This is timer run 0. Means timer 0 run bit. Already we have used this instruction. As this register, TCON register is bit addressable register, so each bit can be addressed. প্রত্যেকটা বিট আলাদাভাবে অ্যাক্সেস করা যায়, সুতরাং আলাদাভাবে অ্যাক্সেস করা যায় বলে নো নিড টু ইউজ দ্য ফুল TCON রেজিস্টার। পুরো TCON রেজিস্টারটা আমার ইউজ করার দরকার হয়নি, শুধুমাত্র আমরা বিট হিসাবে ইউজ করেছি। যেমন ধরো, for running the timer 0 we have used set bit tr0, means actually we have set this bit in TCON register by logic 1. আমরা কি করেছি, TCON রেজিস্টারের এই বিটটাকে লজিক 1 করেছি by using that instruction, which instruction, set bit tr0. Using that instruction actually we made this bit logic 1. Next, this is tf0. This is for timer flag 0. This timer flag 0 means whenever the timer will reach the highest position and after rollover, this bit automatically will set as logic 1. এই বিটটা তখন অটোমেটিক্যালি লজিক 1 হয়ে গেছিল। আমরা কি করেছি, এই বিটটাকে চেক করেছি, JNB TF0 যখন আমরা চেক করেছি, অ্যাকচুয়ালি এই বিটের স্ট্যাটাসটাকে আমরা চেক করেছি। So these two are for the case of timer 0, and similarly this 2 is for the case of timer 1. So this 4 bit is used for timer 0 and timer 1. This TR0 and this TR1, this 2 is for running the timer. This TF0 and TF1, this two bit is used for checking the status of timer flag. So this 4 bit already we have used, and the rest bit means this lower level we will study later when we will enter into the interrupt portion. What is the function of gate bit? What is the gate bit? Gate bit is the 3rd bit and 7th bit of TMOD. There is a gate bit, and normally that gate bit we have used 0 for the case of software operation. Now from this figure, say this is that figure. For the case of software instruction, for running the timer, we have used set bit TR1 or TR0, anything. We have used this one. Now how this operation happened? We have kept the gate pin as 0 when we are using the software timer run. So see how that operation happened. This pin here, this gate pin kept as 0. So when this is 0, this is a NOT gate, so here it will be 1. This is the OR gate. So irrespective of the status of this second terminal, the output is always logic 1. I am repeating. When gate is 0, where is this gate pin? The gate pin is at TMOD, and up to this explanation, always we have kept this gate pin as logic 0. So when gate is 0, there is a NOT gate, so this is 1. When this is 1, this is a OR gate. So what is the another input? It is not important because this is 1 and this is OR gate, so always this should be 1. So by keeping the gate as 0, this is always 1, and this is the 1 input of the AND gate. So when we are using timer run means by using the set bit timer 0, timer run 0, when this is set, then this will be logic 1 and this switch is just 1, just logic 1 মানে হচ্ছে এই সুইচটা কানেক্ট হয়ে গেল। So when this is connected, timer run শুরু হয়ে গেল। তার মানে in this case we have set the gate as 0, only we have used the timer run instruction, then timer is automatically run. Now if we place the gate as logic 1, when this is logic 1, this is 0. When this is 0, whatever will be the value here for running the timer, this should always be logic 1. Now this is the AND gate, so here this pin always should be logic 1 to get the value at here. Now in this situation, when the gate value is 1, this is 0, so to get the value at logic 1 here, most important thing is that logic 1 should be required here. Got my point? To run the timer by using the set bit timer instruction, to run the timer means here we need always 1. When we are using timer run instruction, this will be logic 1. So for getting the logic 1 here, we must need a logic 1 in this position. Now when gate has been kept as logic 1, then this is no doubt 0. So now the timer will only run if the value at this position is logic 1. If the value at this position is logic 1. So this is most important case, means this logic 1, we will use this logic 1 externally, means this hardware signal should be required. One hardware signal should be required to run the timer. One hardware signal should be required to run the timer when we are keeping gate as logic 1. সুতরাং বোঝা গেল, গেট যদি 0 রাখি, শুধুমাত্র this software instruction is sufficient to run the timer, but গেটটাকে যদি আমি অন রাখি, then some external signal should be required to make the timer in running condition. That external signal, from where this external signal is coming, in 8051 P3.2 or P3.3. So this is 2 pin, P3.2 or P3.3. This 2 pin is required, means INT0 and INT1. So this INT0 and INT1, this 2 pin will be used as the external signal for running the timer. তাহলে আমি টাইমারটাকে যদি কখনো মনে করি যে আমি এক্সটার্নালি টাইমারটাকে আমি কন্ট্রোল করব, টাইমারটাকে রান করব, টাইমারটাকে বন্ধ করব এক্সটার্নালি, দেন দিস 2 পিন শুড বি রিকোয়ার্ড, অর উই মে ইউজ এনি অফ দিস 2 পিন। যদি আমি টাইমার 0 ইউজ করি তাহলে P3.2 ইউজ করব, আর যদি আমি পিন টাইমার 1 ইউজ করি তাহলে P3.3 ইউজ করব। Another use of pin 3.2 and 3.3. What are the use? যদি আমি externally টাইমারটাকে কন্ট্রোল করতে চাই, at that point, at that situation, we must give a particular signal at pin P3.2 or P3.3. When we will give that signal, after that, if we use the instruction set bit TR1 or TR0, then the timer will run. This is the hardware control, and to control with hardware, the gate signal in TMOD register should always be kept as logic 1. So I think it is clear. So again, as we are here, INT0, INT1, no doubt this is the interrupt pin, means we want to interrupt signal, then these 2 pin will be used. In that case, if we use this 2 pin P3.2, 3.3 as an interrupt pin, then first we should set by the instruction that we are using P3.2 and P3.3 as the interrupt pin. আমি যদি ইন্টারাপ্ট হিসাবে কাজে লাগাতে চাই, সেক্ষেত্রে আমাকে আগে সেট করে নিতে হবে যে আমি 3.2, 3.3 কে আমি ইন্টারাপ্ট পিন হিসাবে কাজে লাগাচ্ছি। আর যদি এইরকম ভাবে কাজে লাগাই, দ্যাট কি ক্ষেত্রে, যে যদি আমি চাই যে আমি টাইমারটাকে এক্সটার্নালি কন্ট্রোল করব, দেন অলসো উই ক্যান ইউজ দিস P3.2 and P3.3 pin, and in that case some external signal will be given from here to run the timer, and after that we will use the set bit timer running operation, and we will use the timer.